Assalamu alaikum. In this lesson, we will continue what we've discussed previously concerning Chapter 3, Oxidation Reduction Potential. At the end of this video, you will be able to define the redox potential and the standard potential of a redox couple, to classify the redox couples with respect to the hydrogen couple according to their redox potentials, predict according to the established electrochemical classification whether a redox reaction takes place or not. Please make sure to prepare your pen and a notebook in order to take notes. You've learned previously that the galvanic cell is an electric generator, composed namely of two metals with different reactivities, where for example 0.46 volt is produced when silver ions gain electrons from copper metal according to gamma rule. The overall reaction here will be Cu plus 2Ag plus will give Cu2 plus 2Ag. However, it's not enough to stop here. You must continue and think, how can we calculate this voltage produced from those two metals simply with simple calculations? And how are these metals classified in this electrochemical classification? Why is Cu more reactive than Ag? This problem will be solved during this lesson. Let's start off by mainly explaining the title of this lesson, Oxidation Reduction Potential. What is a redox potential? Well, concerning this battery, you've taken in physics that a voltage represents the potential difference between the two terminals of the generator, also known as U in volts. So that the rule will be U of the generator equals UPN, V of the positive terminal minus V of the negative terminal. V here represents the potential, and here is the difference between them. And you've also taken that this same rule is equal to E minus Ri, where E is known as electromotive force, and Ri is the energy lost in the form of heat in this electric generator. So some generators lose some energy in the form of heat. However, other generators are considered as ideal. This means that no internal energy is being lost, so that the Ri here given is equals to 0. Then simply the potential difference of an ideal generator is equals to E, the electromotive force. In our study of a galvanic cell, this galvanic cell is considered as an ideal generator. So the potential difference of the galvanic cell will be equal to the electromotive force of the cell, which is, as we said, is equal to the potential difference between the two electrodes, the positive and the negative. And here in the galvanic cell, we know that the positive and negative poles are the anode and the cathode. And this is the simple rule. E of a cell equals V of the cathode minus V of the anode. Now let's apply this rule on different galvanic cells. Hold your notebook and try to solve the following applications. The first galvanic cell here gives a voltage of 0.46 volt between the copper and silver metals. Remember that the potential difference is the difference between the positive and the negative poles, the potential difference between the two electrodes, the positive and the negative. And what are the positive and negative poles? The positive pole is the cathode, which represents the Ag half cell, and the negative pole is the anode, which represents the copper half cell. Then the redox potential here will be equal to the voltage of Ag plus Ag couple minus the voltage of Cu2 plus Cu couple, which is equal to 0.46 volt, the voltage read in this galvanic cell. Now for our second galvanic cell here between the copper and zinc metals, the voltage given is 1.1 volts. Given that electrons flow from Zn to Cu, can you find the redox potential of this galvanic cell? Well, I think that the rule is simple here. As we said, we must find the difference between the cathode and anode, the positive and negative poles. In this case, the cathode is for the copper redox couples, and the anode is for the zinc redox couples, which is equal to 1.1 volts. For our last example here, given the following galvanic cell. However, the flow of electrons here is not a given. So can you tell me how to distinguish between the cathode and the anode in this galvanic cell? Observe the figure carefully and tell me which one of the two half cells represents the anode and which one represents the cathode. Well, in the previous lesson, we've learned that the negative ions will migrate towards the anode and the positive ions will migrate towards the cathode. So the cathode here will be for the zinc couple and the anode here will be for the magnesium redox couple. the difference between them will be equal to the voltage read by the voltmeter, which is 1.61 volts. So for now, you've learned that the redox potential of a galvanic cell is the same as E, which is equal to the difference between the cathode and the anode, equal to the voltage read by this galvanic cell, in this case 1.1 volt. However, what is the value of V cathode and V anode? In other words, what is the potential of each redox couple and how can it be determined? What is the potential of Cu2 plus Cu, Zn2 plus Zn, any other kind of metal? This will be our talk on studying the standard reduction potential of metals. In order to find this standard reduction potential, by convention, we will use the H plus H2 couple, the hydrogen couple, as a reference. And as a reference, its standard reduction potential will be given a value of 0. So this value here, which is 0, will be the standard reduction potential for the hydrogen redox couple. By using this important information, how to find the standard reduction potential of the other metals? Let's be clever here and think. We know that we have a galvanic cell and the standard reduction potential for hydrogen couple equals to 0. How can we use this important information in order to find the standard reduction potential of a metal? We will combine the two information in order to build a galvanic cell containing this hydrogen redox couple. So the galvanic cell will contain an electrode containing the metal with the unknown standard reduction potential and an electrode containing the hydrogen redox couple with a known standard reduction potential equals to 0. This video is prepared and recorded by teacher Zahra Shiri and supervised by teacher Hiba Badawi. Thank you for your time.